Welcome. A sequence is a set of numbers arranged in a definite order. The following numbers form a sequence: 2, 5, 8, 11, and so on. Do you see the pattern? Right, it increases by 3. You might have a job interview one day where they ask you to recognize the pattern and determine what the next number in the sequence is going to be. And there's all kinds of sequences. This is just one type of sequence. It's called an arithmetic sequence. Okay, the numbers in a sequence are called the terms of the sequence. If a sequence has an infinite number of terms, it is called an infinite sequence. So if it has that ... at the end, it's called an infinite sequence. That ... is called an ellipsis. A finite sequence has a first term and a last term. No ellipsis. In a sequence, the first term is denoted by A1. The second term is denoted by A2. The third term is denoted by A3, and so on. Using subscript notation, we can represent an infinite sequence by writing A1, A2, A3, ... AN ... If it's finite, then we just don't have the ... at the end. The term A sub n, so you could say A sub n, or if you just say AN, that's fine. A sub n represents the nth term, also called the general term. Okay, the general term of a sequence can be used to calculate terms of the sequence. So here's our first example. Find the first 5 terms of the sequence that has the general term. So here's our formula. AN equals 2n plus 1. So the first term is A1, A subscript 1. The second term is A2. The third term is A3. The fourth term is A4. And the fifth term is A5. So we're going to plug in n equals 1 and work it out. And then n equals 2 and then work it out, and so on. Okay, so here's the first one. Replace n with 1. So that gives you, everywhere you see an n, replace it with 1. So that gives you A1 equals 2 times 1 plus 1. 2 times 1 is 2. 2 plus 1 is 3. So there's the first term. Do the same thing for A2 and A3 and A4 and A5. Okay, you might want to pause the video and work that out. So we have our 5 numbers: 3, 5, 7, 9, and 11. If you didn't work out the last couple because you kind of saw the pattern already, that would be fine. You can see that it increases by 2. As soon as you see 3 and then 5 and 7, oh yeah, I can see what's happening. It's increasing by 2. And that's because of the 2 in front of the n. Here's our next example. Again, the same directions. We want to find the first 5 terms. This one isn't as easy though. It's actually called a geometric sequence. But again, what we're going to do is plug in n equals 1, work it out, n equals 2, work it out, etc. So when you plug in n equals 1, you get 2 to the power negative 2. So we have to know our rules with negative exponents. You can use your calculator if you want. It should give you 1/4. But whenever you have a negative exponent, You move the term to the denominator, put a 1 on top, and then the exponent becomes positive. So that gives you 1 over 2 squared, which is 1 over 4. And then 5 times 1/4 is 5/4. Okay, try to work out the rest. The second one is 2 to the negative 1. 2 to the negative 1 will be 1 over 2 to the 1. That'll give us 5/2. 2 to the power 0 is 1. So 5 times 1 is 5. The last two are easier. 2 to the 1 is 2, so 5 times 2 is 10. 2 squared is 4, so 5 times 4 is 20. So we have our 5 first terms of this sequence. Okay, same directions. Find the first 5 terms. A sub n equals, in parentheses, n plus 1 times, and in parentheses, n minus 1. Okay, so the same idea. For the first term, plug in n equals 1 everywhere you see an n, and then plug in a 2 for n for the second term. And for the third term, plug in n equals 3, etc. So here's our first term. A1 equals 1 plus 1 times 1 minus 1. And that gives us 0. Now for A2, we plug in a 2 everywhere we see an n. So 2 plus 1 times 2 minus 1. And that gives us 3. Now for A3, 3 plus 1 times 3 minus 1. That gives us an 8. A4 is 4 plus 1 times 4 minus 1. 15. And A5, 24. 0, 3, 8, 15, and 24. Again, I probably went through that too fast. You got to pause the video. You should be able to work out each of those on your own. So here's that sequence that we were talking about at the beginning, 2, 5, 8, 11. For the sequence, the difference between a term and its preceding term is always 3. So for this sequence, it increases by 3. If you subtract 5 minus 2, you get 3. Or 8 minus 5, you get 3. 11 minus 8. So a number subtracting its previous term is always 3. Okay, so whenever that happens, that gives us an arithmetic sequence. If it increases or decreases by the same number, it's called an arithmetic sequence. Here's a definition of an arithmetic sequence. It's a sequence in which the difference between a term and its preceding term is a constant. So when we get the same number, it's called an arithmetic sequence. The number d is called the common difference for the arithmetic sequence. So for the arithmetic sequence above, the common difference is 3. Now here's the formula that you probably want to memorize. The general term of an arithmetic sequence. So for an arithmetic sequence, the general term is a sub n equals a1 plus n minus 1 in parentheses, n minus 1 times d, where a1 is the first term and d is the common difference. So what we learned previously is how to get the terms from the formula. Now we're going to try to find out how to find the formula from the numbers. So if we have that 2, 5, 8, we want to know what is the formula, what's the general term formula that will give us those numbers. Okay, and we're going to use this formula. So this is one of the formulas, to make sure you write it down. In this chapter, in these next two sections, for arithmetic sequences and geometric sequences, we're going to have quite a few formulas. We're going to have 5 to be specific, so 5 formulas for these next two sections on arithmetic sequences and geometric sequences. This is the first one. Example 4. Find the general term for the arithmetic sequence 2, 5, 8, 11. ... So we have the sequence, we have the pattern. We want to know what the formula is that will give us those numbers. So we're going to start with our formula. A sub n equals a1 plus n minus 1 times d. And what we want to find is our a1 and d. So first, let's find d. If we have d, that tells us definitely that it's an arithmetic sequence. So what is our d? Well, d is 3, right? 5 minus 2 is 3. 8 minus 5 is 3. 11 minus 8 is 3. So d is 3. The next thing we want to find is a1. a1 is 2. 2 is the first term. Okay, so I showed a little bit of work for d. You don't have to show that much work. You could just put d equals 3. You could look at that and say, oh yeah, definitely d is 3. So now we have d, which is 3, and a1, which is 2. You're just going to put those into the formula and simplify it, and then you're all done. So here's our formula. Replace a1 with 2 and d with 3. I know it is kind of weird that the d is after the parentheses. You still have to distribute it. It's just traditional. If you want to put the 3 in front of the parentheses, you can. There's no rule against it. So that gives you 2 plus 3n minus 3. Add 2 and negative 3 together. So a sub n equals 3n minus 1. That's the formula that will give us those numbers. See, if you plug in 1 for n, 3 times 1 is 2, 2 minus 1 is, sorry, I said that wrong. 3 times 1 is 3, 3 minus 1 is 2. And then plug in 2, 3 times 2 is 6, 6 minus 1 is 5. Then plug in 3, 3 times 3 is 9, 9 minus 1 is 8. So it does work. Again, I know I did that verbally, but just plug in 1, and then 2, and then 3, and then 4, and you'll get 2, 5, 8, 11. Okay, here's another one. 7, negative 1, negative 9, negative 17. So here's our formula. We need to find a1 and d. Let's start with d. How do we find d? You subtract the second term minus the first term. Or you could see, what is it increasing or decreasing by each time? You could look at it and say, oh, it's getting smaller, isn't it? That means it's a negative. And how much is it getting smaller by? That's right, 8. So if you take a2 and minus a1, that'll give you negative 8. Or A3 minus A2, that'll give you negative 8 also. So we have our D. Now we need to find A1. Well, A1 is just the first term. So we have our D and we have our A1. So plug those into the formula and then simplify it, and you're all done. 7 plus n minus 1 times negative 8. Distribute the negative 8. Add the two constants. So a sub n equals negative 8n plus 15. Okay, same kind of problem. This one has fractions. 1/2, 1, 1 and 1/2, 2, 2 and 1/2, 3, 3 and 1/2, 4, etc. What is D? You can see that it's increasing by the same number, right? It's getting larger. If it's getting smaller, it's negative. If it's getting larger, it's positive. What is it getting larger by? Yeah, 1/2. Or you could always subtract the second term minus the first term. Next, we want to find the first term. Well, the first term is also 1/2. All right, so now let's plug it into the formula. A1 is 1/2. D is 1/2. Leave n alone. You're going to distribute the D and add like terms. So distributing the 1/2 is 1/2 n minus 1/2. And then the 1/2s cancel, so our general term is a sub n equals 1/2 n. The formula can also be used to find a desired term. Example 7. Find the 40th term of the arithmetic sequence 10, 6, 2, negative 2, dot, dot, dot. So do you see what's happening here? We have the first 4 terms listed. We want the 40th term. That's quite a ways down the row, right? We don't want to do that much work. We could keep writing it until we find it. You could see the pattern, 10, 6, 2. What is the pattern? Right, it's decreasing by 4. So the next number in this sequence would be negative 6, and then negative 10, and then negative 14. So eventually we could get there, but we're trying to use the formula to find the 40th term. What if we wanted the 400th term? It would be impractical to list that many numbers. So we definitely like these formulas. Okay, here's our formula. A1 plus n minus 1 times D. What is our A1 and what's our D? Well, our A1 is 10 and D is negative 4. Remember, not positive 4, it's decreasing, so it's a negative 4. And then our n, since we want the 40th term, we're going to let n be 40. If we wanted the 50th term, then n would be 50. If we wanted the 400th term, then n would be 400. So plug those 3 numbers into the formula, and you can work that out on your handy-dandy calculator, or you could do it by hand, it's up to you. Do the parentheses first, then the multiplication following the order of operations. So you get negative 146. That's the 40th term. Again, if you just wanted to type that into your calculator, that would probably be okay with your teacher. Okay, here's a second formula that we're giving to you. depends on your teacher if you have to memorize these formulas. I myself do not make students memorize this formula. I think there's too many to memorize, so if the test is in class, we just have these formulas on the test itself. Okay, so here's our formula. S sub n equals n times a1 plus an all over 2. This is for the sum of the first n terms of an arithmetic sequence. Okay, so what do we need to find this sum? We need a1, we need an, which is the last term. So let's say there's 200 terms. Then a sub 200 would be the last term, the 200th term. And then we need the number of terms n. So we need three things: n, a1, and an, and then we could calculate this. Okay, find the first 40 terms of the arithmetic sequence 6, 10, 14, 18. So here's our formula. We know what n is. N is 40. We know what a1 is. a1 is 6. That's the first term. What we don't know is what the last term is, a sub n. So we're going to find that first. We're going to go back and use that first formula. A sub n equals a1 plus n minus 1 times d. So a1 is 6, d is 4, and n is 40. So we're finding the 40th term. And we're using our first formula that we had. Let's work that out. I didn't show the steps this time. I just used my handy dandy calculator. And I got 162. So that's our a sub n, 162, or our a sub 40. Because we're trying to find, S stands for sum. We're trying to find the sum of the first 40 terms. That means S sub 40. So here's how we work it out. S sub 40 equals, and then on the top it's 40 because n is 40. In parentheses it's 6 plus 162. So 6 is the a1 and 162 is the a sub 40. And then it's always a 2 on the bottom. So type that into your handy dandy calculator and you should get 3360. So instead of adding all 40 terms, 6 plus 10 plus 14 plus 18 plus 22 plus 26, we use the formula and get 3360. All right, another one with fractions. Write down our formula. We have n, which is 58. We have a1, which is 2. What we don't have is the 58th term, which is an. So we're going to use our a sub n formula. Plug in a1 is 2. Let's see, what is d? D is going to be 1.5, 1.5. So A1 is 2, D is 1.5, and N is 58. 1.5 is the same as 3 over 2. or you could use 1.5 in your calculator. Type that all into your calculator and you should get 175 over 2. If you want to change that to a mixed number, it's also 87 and a half, or 87.5. Okay, plug it into the formula. So again, n is 58, a1 is 2, the last term is 175 over 2, or if you put 87.5 or 87 and 1/2, it will not matter in your calculator. It's always good to have a good calculator. I personally, at this point, like the Casio FX 991EX. It's a cheap little calculator. It's only about 15 bucks, maybe $18. And it does a lot of things. Okay, type that into your handy dandy calculator, and this is what you should get. 2595, 2,595 and 1/2. Depending on the calculator, if you're having trouble learning how to use it, there's always videos on YouTube. Just type in your model number that you have, and you'll find lots of videos on that calculator. Okay, here's our next example. This is to find the sum, again the sum, but it's not an infinite sequence, it's a finite sequence. 6 plus 13 plus 20 plus 27 plus ... plus 181. It is an arithmetic sequence, isn't it? It's increasing by the same value. It has a common difference. 13 minus 6 is 7. 20 minus 13 is 7. 27 minus 20 is 7. And it's increasing, so D is 7. We have A1. A1 is the first term, which is 6. How about the last term? Right, 181. We have our first term and we have our last term. What we don't have is the number of terms, n. So that's our goal right now, is to find n. Why do we need to find n? Because in the formula of S sub n, there's an n in it. And if we don't have n, we can't use the formula. So we go back to our first formula, and we're going to plug in 181 for an, because it's the last term. A1 is 6, D is 7, and we're going to be left to find n. Okay, distribute the 7. Add like terms. Add 1 to both sides. Then divide by 7. So you should get n equals 26. It has to be a whole number. It can't be a fraction because n is a number of terms. There can't be 26.5 terms. It has to be 26 terms, or 27 terms, or 28 terms. So n has to be a whole number. If you don't get a whole number, that means you've made a mistake. Okay, so we have all the information that we need to use our formula. We have n, we have a1, and we have an. Again, an is the last term. So plug all those numbers into the formula, use your handy dandy calculator, and you should get 2431. Okay, here's some new notation now. The sum of a finite series can be written using the Greek letter sigma. we say it as an S, but it's kind of like that funky little E there. But it's actually the Greek letter sigma, the capital Greek letter sigma, S. So it's kind of like that E looking shape. On the bottom is I equals 1, and on the top is N. The letter I, in this case, it doesn't have to always be I, it could be another letter. It's called the index of summation. Sometimes we just say the index. So here, as part of the I equals 1 under the S, is called the lower limit of summation, or just the lower limit. And on top, the N, on top of the sigma, is the upper limit of summation, or just the upper limit. The index takes on all values from the lower limit to the upper limit inclusive. So that means it includes everything from whatever the bottom number is to whatever the top number is, including those numbers. Although we use the letter I as the index, other letters may be used. It could be an X, it could be a J. In this case, it's just I for index. Okay, so we have this summation notation. In this case, it's the sum of a sub I as I goes from 1 to n. That's how we say it. We read this as the sum of a sub I as I goes from 1 to n. It means to add all the terms in the sequence, starting from the first term and adding through the nth term. So the sum of I equals 1 to n of a sub I has a lower limit of 1, that's from the bottom number, and an upper limit of n. So therefore, in this case, we have n terms, because we're going from 1 to n. Let's look at an example. The sum of 2i as I equals 1 to 5, that means I is going to take on every value from 1 to 5, and then we're going to add each number. So starting at 1, that means 2 times 1, and then 2 times 2, then 2 times 3, then 2 times 4, and then stopping at 2 times 5. We're going to get all those answers and add them up, and then we're done. So in this case, we get 30. All right, example 11. Find the sum of 6i minus 7 as I goes from 1 to 28. So what this means is that we would start with I equals 1. So you would plug in 1 for I. 6 times 1 is 6 minus 7 is negative 1. That would be the first term. And then plug in 2. 6 times 2 is 12. 12 minus 7 is 5. Get the second term. And then go to I equals 3 until we get to 28. That seems like a lot of work though. Yeah. Luckily, we have these formulas that are going to help us out. So we're talking about the sum, and this is going to turn out to be an arithmetic sequence. So think about that formula. It had an n in it, it had an a1, and it had an an. First term, last term, and the number of terms. That's what we're going to need. So what I want you to do is just list a couple of terms and the last term. Okay, let's start with I equals 1. So plug in I equals 1, get that answer. And then plug in I equals 2, get that answer. Maybe plug in I equals 3, get that answer. Just to make sure it's arithmetic so we can really see, yes, this is definitely arithmetic. And then plug in I equals 28 to get the last term. So it's an arithmetic sequence. We're going to replace I with 1, 2, 3, and 28. So start with 1. 6 times 1 is 6. 6 minus 7 is negative 1. So negative 1 is the first term. Then plug in I equals 2. 6 times 2 is 12. 12 minus 7 is 5. That's the second term. Then plug in 3. 6 times 3 is 18. 18 minus 7 is 11. Then plug in 28. 6 times 28 is 168. Minus 7 is 161. So those are our first 3 terms and our last term. You might want to pause the video to make sure you get the same calculations. Okay. So here's our formula. So we're going to use this formula. We know what our n is. N is going to be 28. When it starts out at 1, it's always going to be the top number. It doesn't always have to start at 1 though. So here's a formula that we're going to need. In general, the number of terms is the upper index minus the lower index plus 1. So in this case it's 28 because 28 minus 1 plus 1 is still 28. But if it doesn't start at 1, you definitely want to use that formula. It's going to be the top number minus the bottom number plus 1. That'll give us a number of terms. Okay, so plugging that in, we get n equals 28. The last term was 161, and our first term was negative 1. Plug those numbers into the formula, and then insert it into your handy-dandy calculator, and you should get 2240. A couple of more problems, we're almost done. Let's do another one. The sum of 3i plus 1, and by the way, as soon as you see a number times I plus or minus a number, that's an arithmetic sequence. That's the pattern. AI plus K or AI plus B. Okay, so again, let's do the same thing. Let's start at 12. Let's list the first maybe 2 or 3 numbers of our sequence and then our last term. But we're not starting at 1 this time, we're starting at 12. Because that's what I equals. I starts from 1 to 63. So you're going to plug in I equals 12, and then 13, and then 14, and then the last term, so then dot, 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 and then 63. Okay, 12, 13, 14, dot, 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 63. So I got 37, 40, 43, and 190. Pause the video, make sure our math coincides. Okay, so now we're going to use our formula. We need n. N is the number of terms. Remember, to find the number of terms, it's going to be the top number minus the bottom number plus 1, right? So A1 is 37, N is 52, A52 is 190. Again, I got the 52 from 63 minus 12 plus 1. Plug everything into your handy-dandy formula. Then from there, insert it into your handy-dandy calculator, and you should get 5902. All right, last problem. I equals 3 to 7, so there's some good news. Not very many numbers, 3 to 7. That means it starts at 3, and then 4, and then 5, and then 6, and then it stops at 7. Oh, but look at the inside, I squared plus 1. It's different, right? Doesn't look like the last two examples. So let's start with 3, because that's what it starts at, 3, 4, 5. What do we get? So 3 squared is 9, 9 plus 2 is 11. 4 squared is 16, 16 plus 2 is 18. 5 squared is 25, 25 plus 2 is 27. Let's see, what's the common difference? See, the first one, it goes up by 7, but the next one goes up by 9. It's not arithmetic. So the reason we put from 3 to 7 is because I made a problem that wasn't arithmetic. In this case, we're just going to have to write down all the terms. So we're almost there. We're almost halfway there. We got to just plug in, oh, we're more than halfway there. We just got to plug in I equals 6 and I equals 7, and then add them all up. So you should get 11 plus 18 plus 27 plus 38 plus 51, and that gives you 145. So by the way, on your calculator, if you have a Casio, you should have a summation button. If the Casio 991, it's where the X is, so you have to just hit Shift and X, and then you could actually type this into your calculator. So if this is a, let's say, multiple choice test, or you don't have to show the work, you can just type it into your calculator. If you do have to show the work, well, you can still use your calculator to check your answer, but you still got to show the work. Okay, so it depends on your instructor. In math, usually we're all about show your work. Okay, that's it for this video. I'll see you here for the next one. Have a good one.